Sean, and we're live again. Once again, thank you so much for chilling out and checking out that Patreon commercial. My name is Brian Miller. I am a founder of a company called Zapmill LLC. My focus is unbound learning through lifelong experience. Basically, meaning I make educational games and I also teach game design and game development. And so tonight's final episode of Unity certification kind of falls into a very special reflection of what I work on and what I practice. So with Josh here tonight, do you prefer Josh or Gur?
Gur.
Gur. All right, thank you. Gur, he's going to be working with us and teaching us the last segment of getting your Unity certification. If you're unfamiliar with all the game design and development softwares out there, there's tons of them. Unity is one of the leading ones out there, and you can even get your certification from Unity. Certain times of the year, certain locations, they will offer the Unity certification exam. And this is something, if you're looking to break into the industry of game design and game development, this is something you might want to have in your back pocket to fire up, and throw into your resume. It's pretty powerful, I have to admit. So, again, for our viewers who haven't seen part one or part two, definitely be sure to go to our YouTube channel and look it up and put that on your playlist. Don't forget to hit that like and subscribe button. We really appreciate it to help us out. And so I'm going to kind of quit bumping my gums, and I'm just going to go ahead and let Josh take over. Right? Josh, you ready to take over?
Yeah, man. Ready when you are.
All right, cool. The show is all yours.
Hello, everyone. Welcome to part 3 of the Unity certification exam. I'm Gur, and I work as the VR experience designer as well as the head of teaching at Black Box Realities, a VR design studio in Nashville, Tennessee. Right now, we've been going over a few different pieces. Let me go and share my screen so we can get this ready and rocking. There we are. We got Brian's cool little logo here, but we're going to pop that right out of the way. We're going to just jump right into it today. Today, we're going to be discussing programming and scripting. This is the third chunk of the Unity certification that you do need to know. Part 1, if you can remember, was about pre-production, all the stuff Unity wants you to know that are more of soft skills, such as the pipeline of development, I should say, the different things that Unity wants you to know as far as their services and what they can offer you to assist in your development and also to make the money. and it was also a time where we were discussing the different roles within the game industry. Part 2 was all about the engine itself, all about the different workings in the engine, all these windows and what they do, making things within Unity, assigning tags and layers, as well as understanding how different components work. So going through that today, what we're going to be doing is we're going to be making a few different scripts that do different things, as well as we're going to be understanding when certain functions in the scripts get called. We're going to be understanding the Unity API called mono behavior, and we will also be discussing object-oriented programming. Just for everyone to be understanding before we jump in, however, it's important to note that the Unity certification exam does not expect you to be a high-level programmer. They do expect you to know some things about programming, however, because Unity does not have a natively built programming graph API, or rather I should say something akin to UE4 blueprints or any kind of visual scripting system. There are some available, such as Bolt and Playmaker being the most popular one. But in case you don't want to do any of those things, you can, of course, program in C# and JavaScript, which is their own flavor called UnityScript. However, it is important to note, UnityScript is being deprecated in favor of only having C#. So, without further ado, let's just jump right in. Right here, what I have is my basic Unity scene. We're going to be hanging out in here for a little bit. However, we're not actually going to spend too much time in here because most of our work will be done in Visual Studio or MonoDevelop or what have you as what you use for your scripting editing software. A few things I want to go over though before we jump into scripting. The first is how you should set this up in your project. What I tend to do is I tend to create a new folder and I just name it scripts. Super simple, easy to remember, and jump right in. Uh, what I also recommend is that if you're working with separate libraries, which in many cases you may be depending on what you use, there's also a plugins folder that you can create. Be wary though. The plugins folder is what's called a protected folder or a named folder. And by that, what we mean is, here, hold on, let me pop out of this. There we go. That means that anything that's put in the plugins folder, Unity is going to do something with. It's going to try to do it by default. For example, like if I have a few DLLs in there, it's going to try to load those DLLs for me so I can do stuff that Unity doesn't natively support or have easy programming for. All right, so what we're going to do is I'm going to dive right into my scripts folder. I'm going to right click into the folder here, and I'm going to create a C# script. Just right there, easy to go. By default, it calls it new behavior script. It would like you, Unity, I should say, would like you to understand that these are behaviors, and that's how it wants you to think, which isn't a bad method for thinking, to be honest. What we're going to call this is my first script, just like that, and boom, we have a script already done. And as you can see in our inspector here, we have a few things going on here. It's going to tell us all the different things that it's going to preload into our file for us to make our job easier. Let's pop right into it so we can learn more about all the stuff that's here.
And I'm going to take this opportunity to let our viewers know that if you have any questions for Gur, please post them in our chat, no matter what channel you are in. We'll be sure to pass them forward. All right? Thank you.
Yes, please. Any questions would be very much welcome, especially since this is a bit more of a complex section. We good?
So I've got a question. With Visual Studio that you're using, are you aware of the Visual Studio Live that's going on?
I do not. What is that?
Apparently, you can, similar to a Google document, more than one person can edit a code in real time within Visual Studio. Okay, sorry. Didn't know if you knew about that. Just sharing the news. It was just released probably about a month ago.
No, but I'm sure my juniors would love that.
I wish they had it when I was in college.
Okay, so jumping right in, we have our first script right here. And right here, Brian, could you tell me for a moment, is this large enough for the viewing audience?
That looks beautiful.
Perfect. Just wanted to make sure. So let's break down the different chunks of things we have right here. And I'm going to be using comments along the way to help us define what's going on. The first thing we have here is our libraries that we are using. We're using two libraries right now that are pre-built into the C++ redistributable system. That being the, not C++, .NET redistributable system that they have. And that is System. And System handles a lot of different code for you that you can natively do with C#. And here we have system.collections and system.collections.generic. These are both excellent ways of dealing with lists of objects that you're dealing with. So that's why it usually includes that, always includes that into your pre-built scripts. So right here, I'm just going to label these as being your libraries. And it's just stuff you pull in to make sure that you can use the code that the Unity API wants you to use. Right here, we have our class. And the best way to think of a class, the way I think of a class anyway, is a lot like a document. Let's think of it like just your standard Word, like English language document. You can think of this as the entire piece itself, like a page. And these two things right here are best thought of as paragraphs. At least that's the way I think of them in my head, so that way it's a little easier for me to go through and talk about. So I'm going to label this as, our, let's just call this our page. Let's just call it a page. And then this right here, I'm just going to label this as a paragraph. And this one here is a paragraph. And so breaking it down like this makes it a little easier to understand how this code is technically supposed to work. But before we jump too far ahead into these, let's discuss what's going on this line right here. And the one thing you have to make sure of to understand is this right here. This is what's known as the class you are extending from. It is mono behavior. That is the class that holds all of the code that you're going to be using for the exam and controls your game state and what happens within your game state. This is just the way that C# calls this. It is recommended that you do understand some level of C# before you go into the exam because they do want you to understand basic programming. You don't have to be a wizard. You don't have to be the master of all things code, but you do have to understand some basic principles, and we will definitely go over some of them here. Okay. Moving on. What we have here are basic data types that Unity wants you to understand. And the best way to think about data types are just little objects of information that you can use throughout your code. We have things such as integers, and an integer, the best way to think of it is just a whole number. Any whole number can be thought of as an integer. We also have strings, which a string, all that is just a collection of words. Of letters, sorry, not words. Of letters. And funny enough, the best way to think of that is that it is a string of characters, because a character, or my char, it can only be one letter, like this. Oop, forgot it only takes one. There we go. On top of those, we have what are called floating point values. And float values are very interesting in that they are decimals. And that's not the only interesting part about them. There's also the fact that in order to use them, you can't just do this. You can't just have a 0.1 there. You actually have to include an F right here in order to properly use it. And finally, well, second to finally, we're going to include a Boolean value. Booleans are data types that represent a true-false statement. So true-false, basically a 1 and a 0 in binary, and is a great way for being able to reach different parts of your code by doing logic checks. When you become a bit further on in your coding career, you'll understand it's not the best thing to use that, but for right now, for your coding needs, it could definitely suffice. The final thing I want to show you is actually a Unity specific data type. Up to this point, we've been discussing different data types that are native within C#, but this one here is actually specific within Unity. And here, it's going to require us to make our own vector 3. A vector 3, the best way to think of that is as an X, Y, and Z coordinate that you use to find a position within your world space. So right here in our void start, void is just a simple way of saying that this paragraph is not going to return anything. Its whole job is just to run whatever is in it. So it's not going to do anything besides what we put inside of it. So what we're going to place here is I'm going to actually specify my vector. if I can actually do that. There we go. And I'm going to create a new vector 3, which is just a way of being able to create a new object. And in this vector 3, what I'm going to do is I'm going to place in 3 different numbers. I'm going to place in 0, 1, and 0. And actually, you know what? I'm going to do 0.5f just to show that piece. So what I've done here is I've specified a coordinate in which I can go to in my world. Unity definitely wants you to understand how vector 3s work because it is very much integral to the way Unity functions and the ways you can do different things within Unity. So going past that, let's discuss, now that we're done with data types, let's talk about start and update, because those, at least in the beginning of your programming adventure and for the Unity exam, those two are some of the most widely used functions in all of Unity. And it's for good reason. That's because void start, the way void start works is that it's called before the first frame, and before the first frame of any part of your game. So it is the beginning of all the stuff you want to nail down before you want your game loop to start. And lower, we have our void update, which is, as it says, called once per frame. So if I say here, this is just shorthand I'm going to use. This is basically, for those of you who are familiar with JavaScript, this is akin to console.log. All this does is it tells our console in the Unity editor something to print. So that way we can do maybe some kind of error checking or want to check certain things about our code. So I'm just going to say hello world because I can't be more basic than that. And I'm actually going to jump back to my Unity code real quick. And I'm going to open up my console, which is in, if you're using a default Unity setup, is right down here. If you can't reach it, go over here. Go to your window and go all the way down until you see console and click that, or you can type in Control-Shift-C. So I'm just going to do that, bring this up, and I'm going to hit play, and you're going to see why this won't work. And as you can see, nothing has been printed. And that's because, important note about code in Unity, it has to be applied to an object in your scene. At least these types do. There are other types. However, for our example right now, we're not going to go into those. So as you can see, I'm sorry, go ahead.
I'm sorry, hence the OOP.
Yes, exactly. Hence object-oriented programming.
And on the sidelines, Blue Hat Zach, who is Zach Smith, is singing
Blue.
your praise. Yes, he's singing your praises in chat. But you helped him pass the Unity certification the first time, so you're great.
Zach, I miss you, man. Either come up here to Nashville or let me come down there. So going forward from that, other things that you can do within the scene here, as you can see here, I have my first script, which is what we called our code earlier. That's in the inspector. And as you can see, we can see all the stuff we put into our code. And you can see different pieces here. For example, our integer right here, we see it coming in, and we can actually dial it back and forth with the inspector. If you just hover right over where my int is, you can actually scroll back and forth on that little handy tool there. But I'm going to set that back to 1. Down here, we also see our hello world. We have our character right here. We have our float value right here, and we even have a Boolean right here. And the Boolean is interesting because it comes in as a check mark. And that's because that Boolean is just a true-false statement, a 1 and a 0, an on-off. So it makes sense for that to be a check mark. Finally, we have, of course, our vector 3. And our vector 3 gave us 3 different fields that we can plug in. And as we know, the reason they look like that is because vector 3 are 3 points in space. If you take a look up here in our transform in the inspector, the vector 3 is, we can use that as a position to place our camera anywhere within the world. So what we're going to do now is, now that I've attached my script or behavior to the main camera. I'm going to save my scene very quickly, and then I'm going to hit play. And when I hit play, what we're going to see is all the hello worlds coming through. I'm going to stop that right there. So we now have a bunch of hello world coming through because it's running once every frame, which is going to be constantly running through the game loop over and over again. But let's see what happens when I put debug log into my start. And now I'm going to hit play. As you can see, it has only printed the code once, and that's because void start only runs at the beginning of the game state. And it's also helpful to note that it runs at the beginning of the game state for any object that is active. For example, and the reason that's important is because if you have a void start and wondering why your code's not working, probably the good reason for that is that you didn't implement it correctly or have it on. So I'm going to just call this object code container. Real good naming convention there. I'm going to remove this component. I'm going to add it right here so it's a little easier to grab. Oh, and also interesting to note here is that in my add component, because I now have the script as a behavior, it's going to start listing it as things I can pull up in my components. So I can just put in just like that and it automatically appears. It's fantastic. So what we're going to do here is, and also if I hit play, it'll start working for us again. Just like that. It's lovely and wonderful. I'm going to turn this off, however. And as you can see, because of the fact that although we are running something in void start, which is a state-based callback or function, basically meaning that it begins at the beginning of the game state, it will also work if you just turn on the object. When I go over this in a bit, I'll show you some better methods besides this that you can use. But for this case, right now, let's just focus on void start. Also, really helpful to note before I go in, take a look at my vector 3 for a moment. When I hit play, it's going to go from 0, 0, 0, and it's going to naturally take in the pieces that we give it. If I take a moment and actually, I believe I can actually do this, I believe. Because you can set defaults if you set them up here in the class. Then I'm just going to remove this right here. Jump back over to Unity real quick. Let it recompile my code. It's not showing it. Oh well. Anyway, that's how we deal with vector 3s. So, continuing on, now that we've gone over the basic functions that Unity likes to use, let's discuss things beyond void start and void update. I'm going to just remove the code that I currently have, just like that. And what we're going to go over now is something very specific within Unity called the execution order of event functions. The way this works is that whenever the game loop is called, it calls different, because the game loop goes from top to bottom, there are things that are called first and things that are called last. And funny enough, start is actually not the first thing that is called when your game loads. Actually, when your scene first loads, the very first thing that's called is called void awake. And this is called at the very beginning of your game, and actually is called before any start functions. And only after a prefab is instantiated, which you should know back from our part 2 discussion. However, it's also important to note here that just like with start, if the object is not active, it will actually not run the code. So that's important to note. Okay. Next up, what we have is actually still not start. We have void on enable. This is personally one of my favorite functions to use because it's a very quick function for you and it's reusable. Start only runs once, and that's important to note. In fact, while I'm going to be doing these, I'm going to be plugging in code along the way so that way we can check it out later. So I'm going to plug in awake here. And by the way, it doesn't matter the order in which I'm putting this in. If I put it on enable above awake, awake will still call first. Oop. On enable, just like that. Next up, what we have is, so this is something called on level was loaded. So this is a little more specific. I don't tend to use this too much. And that's just because it just is a callback, or I should say it's a piece of code that responds whenever the scene loads, depending on the level. So on level was loaded. So if I could check if level was 0 or the first level that you have, then do this. But that kind of ends it for first scene loading. Except for, of course, cannot forget the two other pieces, which does include start. But actually, even before that, because of course there's still more besides start. Start is actually a bit misleading on this one. We have reset. Reset is called to initialize the script's properties when it's first attached to the object and also when the reset command is used. So basically, to break that down, it's essentially used in editor for when the script's pieces of the script begin to load for the first time. So it's important to have that included. So debug.log reset. There we go. And finally, after all these pieces of code, we have void start. And if you're wondering why private's being automatically added to the beginning of these, it's just what Visual Studio likes to do. And I don't try to stop it because it does help with properly typing it. Because by default, C# is a private language. So it will, by default, mark everything as private until proven otherwise. Because I could technically make a private public void start, but I choose not to, and I don't think it would actually probably work too well within context, especially if you're trying to reach it from other pieces of code. And after this, I actually want to show you something a little cool that you can also do that you may not know about start. In fact, I'm just going to preempt this by saying normal start. Void start's not the only thing you can use. If you want to, for example, you want to have a piece of code run but with delayed times, but you don't want to write an entire code routine for it, which I will go into in a moment. You can actually do this and create an IEnumerator start. And this will actually allow you to do a lot of crazy stuff. It does require a yield. Not all code paths return a value. So I could just say here yield return new wait for seconds. And I can just wait about 3 seconds. Just like that. And then I debug log. Coroutine start. Oh, that is true. It does already have that. Tell you what, I'm going to, should have caught that one earlier. I'm going to encapsulate this piece of code real quick in some comments. So that way it won't run immediately. I'm going to bump down here, but I will open that back up after we do our normal one. So now that we've finished up with what happens on the first frame or even before the first frame, all this good stuff happens all in order. That's when we start talking about what happens in update. So update is an interesting idea because it's basically what all games are built upon. Everything from Pong to the latest, Battlefield game to, Detroit Become Human, which is the best game ever. Uh, uh, it relies on the game state being constantly updated over and over, so different things, different images can be displayed upon the screen. In this case, it's great for keeping track of game logic, interactions, animations, camera positions, all sorts of different things that you can use. Specifically, we're going to be talking about 3 different versions of update, although technically we could do 4. In fact, you know what? Let's do 4. The first one we're going to do here is the most important one, which is, of course, update. Update is your very generic, I am doing my thing kind of code. It is going to be updating every single frame and is best for doing logic checks. So I'm actually going to write that down right here. The reason why I say that is because we have something a little more accurate we can do for things that don't include logic. And that would be fixed update. And fixed update is best for physics. And I will right now explain the difference and why. In fact, I'm just going to remove that so it's a little easier to understand. So the reason why we break things out from update and fixed update is because back in the good old days of, I would say, like the 80s or 90s, or maybe even the early 2000s, it might have been a case. This actually had the strongest impact back in old FPS games or first-person shooters. And that's because, say, if we were both running a game at 30 frames a second, we could each shoot each other within the same amount of time. For example, if I were to shoot a bullet, let's say here, if I were to do a transform, rigid body add force, I'm just going to write a piece of code that will do what I want it to do real quick. Add force, and then I just do, I don't know, let's just say 1, actually we'll do 0, 0, 1, so that way it shoots forward. Just like that. The reason why we don't write it in here is because if I am running a computer at 30 frames a second and you are running a computer at 60 frames a second, let's think about that for a moment. That means this calculation will be calculated 30 times for the 30 FPS, while the other person will calculate that 60 times. So that means that the bullet on the better computer will shoot faster than your bullet. And of course, this isn't fair. So that's why fixed update was created. It's based off of a clock, off a fixed time step that's done within the game calculations. And what it does, it's using something called time.delta time, which is just a reliable timer, essentially, that's independent of the frame rate. So interestingly enough, also about fixed update is that it's often called more frequently than update. So that's also another little piece to understand with that. There are 2 more pieces that I'm going to add. The first is early. Oh, they don't have the other version anymore. That's interesting. I wonder if that's a bit of a new thing. Huh. If James is on here, I'd like to ask him about that at some point. What I'm talking about is the fact that there used to be a void early update, so I don't know why it doesn't exist anymore. That's interesting. So there used to be something called early update, and it was called at the beginning of the frame. Then, of course, depending on if there's a time, if the time step has been hit, if not, it'll just run update. If it has, it'll run fixed update. And at the very end of the frame, it'll run late update. This is useful for if you have a bunch of calculations you've done and you need to do some last minute stuff to it.
Hey, Gur, got a question on YouTube from Railroad Studios. Which Visual Basic is this?
This is Visual Basic, I think 2017. I make sure to keep it up to date because if you don't, the linking between Unity and Visual Studio can actually get kind of wonky. There was a time period where I had to constantly reload my code in order for the IntelliSense to work, which is just annoying because although I know most of the code in the API, I don't know all of it. So it's kind of a bummer when you have to kind of look stuff up still. So it's 2017 with dark theme. All right, there we go. So that's all the stuff that runs every frame in this case. There is a bunch of other stuff you can add in here. Like we can start talking about rendering, or we can start talking about all the different things you can do with coroutines and gizmos and GUIs and pausing and destroying stuff. Actually, we should talk about that. So let's destroy stuff real quick, actually. Because there are two pieces of code that are very useful to have that are jointly considered with the on enable and things like that. And these are very object specific functions that are very useful. The first is on disable. Just like with on enable up here, this is called whenever the object is deactivated instead of activated. So right here, I'm going to say debug.log. And in here, I'm going to say on disable. Just like that. And then finally, what I'm going to write here. So this piece of code right here, it's interesting. I use it very sparingly, very rarely, if at all, because it's not extremely reliable. So be aware when you use this. There have been times where I've tried to use this where I'm destroying when I have to destroy an object for various reasons, whatever it may be, and I'm trying to do some cleanup on it, and it just absolutely will not work for me. Destroy. So we have all these pieces of code in here now. So what we're going to do is I'm going to jump right back into the editor where it's going to remove all these pieces, and instead it's going to probably appear blank. Yep. And what I'm going to do now is I'm going to increase up. There we go. So that way we can see everything. It's because it was having a problem with this. Let's find out. Oh, well, you know what? It would help if we turned on our object. There we go. So we have awake, on enable, and normal start. If you remember, we didn't put anything into the update because I prefer it not to go crazy on that. Reset doesn't usually work because it's in the editor. That's kind of my thing with that. So what happens here is if I were to disable the script right here, it will call on disable. And then when I turn it back on enable is once again called. And notice that awake and start have not been called. That's because it only runs once. Now this works both in the component and in the object itself. So be aware of that. What we're going to do now is I'm going to show you the other part. Oh, and also let's take a look at this. On enable and destroy because the object was destroyed because we're exiting out the scene. Right here, what I'm going to be doing is I'm going to remove this piece of code and I'm going to implement this instead. And let's see how things change up. 1, 2, 3. Boom, there it is. And that's just a handy little way of being able to work with your objects without having to write an entire other coroutine. And what happens is, if I remove my component, it will do an on destroy, and it will also do an on destroy when I destroy my object. So be aware of that when it happens. All right, for the final piece of what we're going to be talking about for the final piece of our work is we're going to be going over, let me pop right back in, different things we can do with our code. And let's talk about working with a game object, the piece de resistance, if you will. And that's because game objects are kind of the whole point of a game engine, believe it or not. So I'm going to type in the data type that Unity has for game objects. I'm just going to call this my object. And this object we can do all sorts of different things with. Just for fun, what we're going to do is we're going to do void start. And in start, what I'm going to do is my object dot transform dot position. So what this will do is it'll update where my object is within the world space. And I'm going to set it to a vector 3. So I'm going to set that vector 3 to 0, 0, 1. Just like that. And what's also useful here is we have to make sure that we also tie what object we're going to be talking to. So in our inspector, you'll see this update. Boom, with my object. Now it's very important to load something in here or else you'll get this, a null reference exception, one of the evils, or I'm sorry, an unassigned reference exception. That's a little different. So that just means like, hey, you didn't do this. You didn't plug it in right. If it says nothing, if there's nothing there, so if I plug in like, let's say null right here, which is just a way of saying nothing, there's absolutely diddly squat in here. I think it'll pass me a null reference, I hope. Nope, it'll still do that's fine. I'm going to tie in my main camera because my camera is a game object. And what will happen is, as you can see, the position is currently 0, 0, 0. But when I hit play, it'll jump over to 0, 0, 0. And that's because we didn't tie it in. No, we did. Some reason it does not want to work for us. Oh, wait, yes, it is. I was looking at the code container. Silly me. Yes, so as you can see here, it did transfer from 0, 0, 0 to 0, 0, 1. And let's just see it from here. As you can see, it's at negative 110. And when we pop in, 0, 0, 1. Perfect. And of course, there's a bunch of other things we can do with our code. And I definitely recommend to you all that Unity definitely wants you to know your way around the code a little bit. I would start playing around with everything that my object or game objects have that you can screw around with. For example, you can screw around with its coloration. If I open up the renderer, .material.color, and I can make that any color I want, so I'm going to make that color, let's make it red. And instead of using the camera, because the camera is not a physical object, with mesh, I'm going to use a cube instead. Let's plate that right into the world. There it is. Good looking cube. So two things are going to happen to this cube. First, it's going to move its position, and then it's going to turn red. Boom, just like that. And as you can see, it's changed its position, and it has changed its color to red and created an instance, which you should definitely understand when you start diving into intermediate stuff with code. So that was just a brief overview of the code that is offered within Unity API and all the stuff that pretty much everything Unity wants you to know for the exam. It wants you to know the script execution order. It wants you to know what data types are. They want you to understand some basic code statements that you can make. For those who don't know, this is a code statement right there. Using my page analogy and paragraph, you can think of this a lot like a sentence, essentially. So I would just keep going with that analogy a bit. Um, and this will help you through your exam. I do also say though that you do go through and study up a bit more on your C sharp. However, don't be too worried about it. And I say that because the programming section is actually only one section in the exam. I know it says Unity Certified Developer, but in all actuality, they actually want you to understand more of what's here rather than what you can put in here. It's not super code heavy. There are code heavy exams. I've actually been able to look at the new code exams that they have out with test questions, and it is difficult. It is definitely really good for the experienced developer. But for the Unity certified developer, all they really care about is that you know what's going on in here. One final piece before I hand this back over is I want to show you a little fun thing you can do with your code. I shouldn't say fun, a very efficient thing you can do with your code. And that is right. If I can find it, oh, right, that's because it's in edit. Edit, project settings, script execution order. So this is a bit more control that you can have over your code. I can add in a behavior right here, and I can actually set it up so my code runs one after another. So I'm going to have my first script there, and I'm going to make a quick script right here and call it, that's my second script, just right there. Boom. Let's pop over to our script execution. And I'm going to apply my second script. And as you can see here, I can change around the order of the times in which my code is called. I can even call it before default time where fixed time steps are. And I can do that just so I can make sure that if one piece of code relies on another piece of code for some reason, like for example, if I have a script that I need a bunch of points from in order to work with them in some form or fashion, I can collect those points first and then hand them off to the other script without worrying about what's running first. So that's just a fun little thing to see there. And with that, I would say that with these three different parts, it's put you on the right path to getting down these Unity certification exam. With this, of course, this is a reference to what you need. I would also definitely encourage you to dive into the Unity API itself, go through tutorials. The exam itself isn't extremely difficult, especially if you've made Unity games before. However, I do recommend that if you are a novice at Unity, that you still go through the tutorials for programming, for the engine and whatnot, because this is really just talking about what's on the exam and not so much how to use Unity. And I just want to make sure that you as a developer yourself are prepared for that and understand that everything taught here was about the exam and not about specifically on how to use Unity. And with that, I wish you the best of luck. Brian, I'm going to hand it right back to you.
Yes, yes, yes. I am here. Thank you very much, Josh, for this part 3. So I guess while we have just a couple more minutes, and for any of our streamers, this is your chance. If you're watching the live stream, if you have any final questions for Josh, pipe them into chat right now. Otherwise, I'm going to move on. So if you were to do a quick bullet point of all the to absolutely narrow all 3 parts to its minimum, if it's possible, what would you what would you say? And if you were to say it's impossible, that's understandable.
I will give you. I don't think it would be possible to list everything we went over.
No,
However,
not at
I
all.
can list the stuff that I would recommend that you take a special focus on.
Okay.
Because these are the things that when I took the test during the first time, this is the stuff I had problems with the most. The biggest areas I had trouble with was in lighting, specifically lighting, because I had not, when I first did it, I had very little experience in lighting scenes and baking lighting. And because of that, I tripped up heavily in that section. Uh, it's all some other places where I really tripped up was definitely when understanding sound. Sound was a big one that I tripped up on. Definitely understand what's going on there. Definitely look up some tutorials on that. Navigation is a big one as well, understanding nav mesh and how it works. And of course, also understanding uh, your soft skills. Because when I first took the exam, I didn't know about, they didn't have any material about the soft skills section. So I was kind of flying by the seat of my pants the first time I took it when it came to that section. So definitely read up on that. But other than that, I have a good feeling for people who do take this exam. It's not extremely difficult, but understand when there are the big complex systems, you really do have to know what you're doing. Especially, oh, and one more, of course, the animator. Because when I first took the exam, I wasn't too skilled with the animator and just with toying around with the basic animation component. So to break it down real quick: lighting, sound, animator, and soft skills
All right.
and
So,
navigation.
all right, something cool to keep in mind, and one of the future streams we will be talking about is with Blue Hat Zach, who's going to help us out with working with animations or images and bringing them then to Unity. So
Oh, excellent.
yeah, yeah. If you haven't checked it out, you should definitely check out some of the beginning stages of Blender with Blue Hat Zach, which you can find on our YouTube channel. That's right, YouTube/Georgia Game Devs. Everybody else, please remember that all of our streams are live on Mixer and Twitch and YouTube, which will be found at /Georgia Game Devs. That's right, we love our Georgia game developers. Hi, Zach, or hi, Josh. Sorry, you're not Zach. I guess I should show
That's
my.
okay. Zach's awesome anyway. It's cool.
Yeah, Zach is cool. Here, I will show my ugly mug too. And hello, we're back. Hi. All right. So before we end the stream, real quick, I'm gonna run my gob just a little bit. We're gonna say thank you to our heroes, our Patreon members. That is Stephen Coffee, Burton Posey, Lee Friedman, James Simpson, which is SnarfQuest. If you don't know anything about that, go look up SnarfQuest. Trey Carpenter and also Joe Casaval. Puzzles by Joe. There are Patreon supporters, so your support helps us with efforts to improve game developers and their community, as well as helping bring better games to life. Our stream is also for gamers looking to learn more about what goes into making their favorite games, as well as designers looking to break into the industry. And it's for experienced designers looking to improve their skills, like passing the Unity 3D certification exam. All right. Next, social media. You can always find us on Twitter and Instagram at ggda_org, or you can find us on our Facebook page, which is facebook.com/groups/ggda.org. So GGDA stands for Georgia Game Developers Association. If you don't know that by now, what's your stutter? Anyway, also so far, if you're here in Atlanta for the first weekend of October, definitely go check out Siege, which is siegecon.net, which stands for Southern Entertainment Interactive Gaming Expo. I got it right again. All right, cool. And then let's see, June 12th. That is the June 12th of 2018 for our late viewers. The GGDA meeting is going to be at the Georgia State University. You can go to ggda.org and find out more information about that. Also, I'm not wearing a shirt tonight, but you can forgive me. The Georgia Game Developers, we do have stuff for sale. We have shirts, which will give you more HP. We have coffee cups, which will give you more intellect. Josh, you can confirm the coffee cup at least, right?
Oh, absolutely. I feel smarter every time I drink from it.
I love it. All right, cool. And also, like I said, we are streaming on 3 different channels. That is Mixer, YouTube, and Twitch. All of those are found at /Georgia Game Devs. And that is about all I am going to spam you guys with my voice tonight. Thank you very much again, Josh, for this part 3 in Unity certification tutorial. Everybody else, thank you so much for tuning in. And, before we go, I'm going to throw one more commercial in everybody's face. So, again, Josh, thank you very much. Good night. All right, there's a salute. Good night, everybody.